So I'd like to talk a little bit about how I repaired this Panasonic DMR-EZ475V. Now this unit belonged to my old neighbors as a double entendre because they're my previous neighbors and they are also old. And they have a lot of VHSs that they still want to watch. And so when this stopped working, they went online and tried to find a replacement, but I guess they don't make VCRs or VHS players new these days. Maybe they do, and they're just too expensive. I haven't looked them up myself. I'm sure you can find used ones, but I went over for dinner to their house one evening, and they asked if I could fix it for them, or at least attempt it. And normally I'd say no to something like this. However, they're essentially my surrogate grandparents, so I couldn't say no. So I'm going to walk you through the steps that I took and what I found. The repair was not straightforward, and I had to jump through a couple hoops, but it works now, and hopefully this will help you with yours if you have similar symptoms. So I'm making this video after I did the whole repair, because when I got into it, I just figured recording at the same time would have been adding a layer of complexity. It was already kind of a big job, so I didn't want to get into that. Of course, in hindsight, I should have, but here we are. So the first thing that we were greeted with when it was powered on was error code here of F06. Now, the service manual for this unit is available online, which is wonderful. It's got schematics and block diagrams, and it also decodes those error codes. So without that service manual, I don't think I could have made this repair. So that F06 was essentially saying that the carriage for the VHS, let me get you up a little higher here. The carriage that the VHS rides on when you push it in, this one right here, was stuck between the down position where there's actually a VHS in here and it's getting ready to play or could play, and the eject position when it's fully retracted. And so that was the place to start. And actually when I got the unit, or when we were at their house and we were looking at it, there was a VHS stuck halfway in there, and we were able to kind of force it to take it out so they could hold on to it. But that was basically, it was a great clue. I mean, that's what told us where the problem was. And it was just that the carriage was not moving. So the first thing to do was figure out what moves the carriage, and it's actually, after moving it manually, you can see this little motor over here on the side. The little coupler on it rotates when you move the carriage manually. So that was clear that this motor is in charge of what they refer to as loading and unloading. So that's a loading and unloading motor. So what I did was I disconnected the connector here and applied 12 volts with my adjustable power supply to the motor directly without anything else being powered on, and the motor spun fine. And so that told us that the motor's okay, and the problem is somewhere else in the circuitry. So when I applied the voltage to it, I was able to move the carriage down and then moved it back up to the eject position. Once it was in the eject position, I applied power to the unit and the error code was gone. And it basically went into normal operation. The DVD player would work, and anything that didn't have to do with the VHS player worked. You can go through the menus and things. And so that was pretty obvious. And we just had to trace back what drives this motor, and our problem was probably there. One thing I do want to note, actually, before we go any further, was when I first opened the unit, I think 5 or 6 of these power supply filtering capacitors here had blown up, and so I'd replaced those first, and before I actually started troubleshooting the carriage, and kind of crossed my fingers that maybe that just would take care of the problem, and hope that it didn't cause a problem downstream. Unfortunately, the latter seemed to be true. But the strange things about these are they have very not standard values. I think like 560 microfarads and 1800 microfarads and 1200 microfarads, just ones that I didn't have in stock, so I had to order them. But that was interesting to find. And so after I replaced those, the problem still remained, and so that's why I had to dig in and take a look underneath this board in the back. So I'm referring to the board in the back. It's actually this brown circuit board, which they refer to as the main PCB. And on the top, we just see a bunch of, well, mostly capacitors, but through-hole components with these jumper wires. But on the underside, there are actually a handful of integrated circuits, and so it's actually pretty complex underneath. And so from the service manual, again, it was wonderful to be able to find, we found this schematic which shows us this chip right here. And now this chip is in charge of driving two different motors. One, the cylinder motor, which is this guy here, and the loading and unloading motor. So I guess it's a proprietary Panasonic chip, which you cannot get these days unless you take it from a good functioning unit. But they packed in the control or drive circuitry for those two motors into a single chip. Now, on this diagram, which page or section 11.6, if you're looking at this too, we can see that here's the same chip, and we can see the control circuitry for the loading and unloading motor on top, and then the control circuitry for the cylinder motor here on the bottom. The interesting thing is that they have pretty much no interaction with each other, and aside from some of the supply voltages. I added in this little, for my own note here, the drive motor voltage is supposed to be a plus 12.3 volts. So what I did was I actually took everything out of the chassis here, which was a pain, and flipped it over and put it all back together and got it to basically function upside down and out of the chassis. And I also soldered on two little test wires, some I think 30 gauge solid core wire, to pin 5 and 6 on this chip here. And then I was able to looked at those with my oscilloscope, and I could see when I went ahead and pushed in a VHS into the carriage, I would see a logical high signal appear on the loading line or at the loading pin. And similarly, when I press the eject button, after I would have to reset everything manually to clear the error, because that would immediately cause the error to come back. Actually, I think in F04 it had like a failure with the loading. So after I reset everything, then I would press the eject button, and I would get a logical high on the unloading signal. So basically what that said was we had from this controlling IC, the proper signals, or at least what seemed to be the proper signals, coming at the right times into the drive circuit or drive chip. But of course, through all of this, we weren't getting any motor signal, or the motor was not moving. And so basically that narrowed all the problems down to this chip here, because we had signals coming in and we know our motor was fine, but the input signal was not getting to the motor, and this was the only thing in between. So basically what this meant was in order to fix this, we would have to make a circuit that basically emulated the behavior of this top part of this chip, and then we would solder the wires to the circuit board at the appropriate locations to tap into the loading signal, unloading signal, the voltage supply, ground, and then also provides the outputs to the motor. And so I found this chip here. It's a ST-L293D, which is just a basically you could build an H bridge out of it, but it's got these four semi-independent drivers, and I'll show you a schematic of it in a second. But basically, I fed the loading signal into the input, and the unloading signal into the loading signal into the input 1, and the unloading signal into input 2, and then we had the motor connected from output 1 to output 2. And so when you got a high on the loading signal or the M1 signal, and then there's going to be a low here, then it would drive the current in one direction, spinning the motor. in one direction, and then conversely, when you apply the high signal on the input 2 to unload it, there's a low on input 1, then the current will go the opposite direction, so with the motor. And so that's essentially what this other chip was doing, or what it seemed like it was doing, and that was enough to get it to go back into proper operation. So I mounted this after I built the original circuit on a breadboard, and then once it was working as I was expecting, I went ahead and soldered it to this little board here, and 3D printed a mount for it, and just put 2 little screws, tap the this panel here. They stick out. I'll show you that in a moment. But then this little harness here goes underneath and makes all the connections on the back of this main PCB. And so these wires are carrying the logic 5-volt supply, the 12-volt supply, ground, input, or the loading and unloading signal, and then the 2 signals that go, or the drive signals that go to the motor. That's all in this harness here, and it goes to this little circuit that emulates the behavior of the original. Real quick, you can see the ends of the screws that hold the circuit board in place. Now, it's kind of hard to tell. I wouldn't really notice it unless you really pointed it out. So this sits in a cabinet tucked away, so no one will ever see it. So yeah, I think that's just fine. Alright, well here's the schematic. It's pretty terrible, but it should hopefully get the point across. Here we have the load signal coming into input 1 on the L293D, and the unload signal coming into N2. And I just added these 10Ks as pull-down resistors just to make sure that the signal that's not being driven, or when the whole system is in idle, that nothing's floating and nothing is going, no noise, if noise gets coupled in, that it won't affect the driver. At the same time, I also put these some small signal switching diodes kind of in a logical OR configuration so that when there's a drive signal coming through, it will enable the chip and then allow current to be sourced through the output. And that also has a pull down resistor for the same reason, just to make sure, especially this one's probably the most important one, is that when neither signal is being driven, noise can kind of collect here and might enable the chip. Unlikely, but it's cheap insurance. And of course, I mean, this would be more important in a battery powered situation where you don't want to have any sort of a leakage or any sort of active output unless you actually want it, because there could be some current draw or current flow that you don't want unless you're driving the motor. But I just figured all this was just kind of make sure it's stable and for it to behave as we expect and as we want it to, because I'm still not exactly sure how the other chip functioned, and this is just my best guess, and just wanted to, since it's a one-off device, it doesn't really matter if you use a few extra components, in my opinion. So that's all that's going on there on that circuit board. And I did put some decoupling capacitors and storage capacitor there, since it's sitting far away from the power supply. I didn't draw those in, but those go in the standard locations just across the supplies, and as close to the supply pins as you can get. One more thing to note, I guess, for this particular type of chip, motor drivers in particular, they have a bunch of extra grounds. As you can see, there's 8 grounds. Normally you just have 1, and that's for thermal, or for heat sinking, basically, because if you're driving a pretty big motor, a lot of current's going to be flowing and a lot of heat's going to build up inside of the chip, and that helps dissipate it. So make sure if you do put one of these together to connect all the grounds together, and then to some thermal mass. I made a very large, relatively large row of wires and solder, like a little pipe basically, and so it just felt like, I mean, it's a small motor, but it felt like that was enough to kind of dissipate the heat, because it doesn't run but for a few moments actually during the load and unload cycles. But if your situation is different, if you were to use this chip for something else, you want to make sure that there's proper heat sinking so the chip doesn't overheat, and then you'll have problems. Alright, so I guess the last thing to do is just to show that it does in fact work. So even though you can't see all the signals flowing through the wires here, you can at least see the mechanism in action. So you can stick in this VHS. It just takes it in just fine and loads it in. So now we're set, and then if we want to take it out, press the eject button and it reverses itself, and there you go.